distillation column and boiler system. We will see in the instrumentation perspective. Distillation column. This is a binary distillation column. Binary distillation column means it will be separated in two parts. Whatever the feed contains, it will be separated into two components. Here, in this case, it is separated into benzene and toluene and diphenyl. Toluene and diphenyl is the bottom product. It will be in liquid state and benzene will be in vapor state. So here, Fe will get. Top product is vapor and the bottom product is in liquid state. The process variables here are the benzene flow rate, that is vapor flow rate, or after condensation benzene. So benzene is one of the process variable, that is D, as mentioned here, that is D. Composition of benzene, that is purity of benzene. Composition of benzene, that is second process variable. And the third one is level, because for safety aspect, the level has to be controlled. And the fourth one is level in the accumulator. So here the benzene is coming here as a vapor. First, let us see how it works. The feed consists of both benzene as well as toluene plus diphenyl. So here, because of a particular temperature and pressure, it will be separated into two components. One is benzene, another one is toluene plus diphenyl. So here, to have better outflow rate, that is better quantity, the benzene flow rate has to be controlled. This is to get the quantity, required quantity. Second one is the quality of benzene is important. That's why composition control is there. That is quality. Third one is level, that is safety aspect. Level should not increase above certain level. That is also safety. It should not fall zero also. That's why level has to be controlled. The third one is reflex ratio. That is a level in the accumulator. The benzene in the vapor product is condensed by cooling water. Here, this heat exchanger will convert this vapor into liquid. That liquid will be stored in that accumulator. From there, it goes out as a finished product. So here, through this, it comes out as a finished product. To control this level here, reflex ratio is there. That is also to control temperature, as well. It can be taken as to control temperature, or it can be used as to control accumulator, like that. Here it is acts as a accumulator level control. If the level increases means too much vapor, then it level will increase. In that case, we have to increase the reflex ratio. Suppose the cooling temperature decreases, cooling water temperature decreases, in that case also the liquid will increase. It means cooling water temperature decreases, it should not affect the temperature inside that distillation column. To avoid that, we are sending more reflex ratio. Like that, here we are controlling the level for any change in cooling temperature or increase in vapor product. For both, we are controlling this level. So these are the four process variables. What are the manipulated variables here? The manipulated variables are one is the flow rate of benzene. Flow rate of benzene for composition control. For composition control, flow rate of benzene is used. That is flow rate of D. That is used one manipulated variable. So to control benzene quantity, for that we are adjusting the steam flow rate. If benzene product decreases, we have to increase the steam so that the temperature will increase inside and the vapor will increase so that the product will increase. That way, we are increasing the steam flow rate depends upon the benzene flow rate. Therefore, for that WS, steam flow rate is manipulated. Second manipulated variable. Third manipulated variable, to control H, we are adjusting the bottom flow rate. That is liquid flow rate. FL is adjusted to adjust the level H. Therefore, P is, that is FL is adjusted to adjust H. And for level in the accumulator, to control this fourth one, the manipulated variable is reflex ratio. Reflex ratio. That this flow controller will adjust the reflex ratio to control the level in the accumulator. So these are the four variables. Here also, four cross variables, four manipulated variable means how many combinations are possible? 24 possible combinations, because 4 factorial. That's why 24 possible combinations are available, out of which this combination gives better, qualitatively better control, better quality of control it will give. Less interaction. Why we are selecting this? Less interaction. Fast response, less dead time. So considering less interaction, fast response, less dead time, considering these three factors, direct effect. By considering these four qualitative analysis, we selected these variables. Let us see once again what are the process variables. Process variables are benzene flow rate. The second one is composition of benzene. This is to check the quality. Third one is level in the accumulator. Fourth one is level, bottom level in the distillation column. What are the manipulated variables? To control benzene flow rate, we are manipulating the steam flow rate. If we increase the steam, the benzene product will increase. If we decrease the steam, vapor will decrease, so that this flow rate can be adjusted. For composition control, we are regulating the benzene product. If composition is, suppose composition decreases, it means what? Quality is less. So that we are decreasing the outflow rate. As outflow rate decreases, what will happen? This level in the accumulator will increase. As level in the accumulator increases, this reflex ratio will increase. The reflex ratio will increase to compensate this composition control. At the same time, this flow rate decreases. That's why steam flow rate also will be increased to increase the temperature. Both ways, this will be controlled. Composition control is controlled by benzene flow rate, and level in the accumulator is controlled by reflex ratio, and bottom level is controlled by liquid flow rate. So these are the four best combinations out of 24. How we got all these things? By considering less interaction, fast response, less dead time, and direct effect. By considering all these four factors, we consider this 4 manipulated variables. The next,